Good day, ladies and gentlemen. This is Sarel van Grennen, aka Mr. VG, and I am now on the second last video in this series on statistics. And I'm going to specifically today look at a statistics question that came from a previous year's exam paper. So buckle up and enjoy. But you first try this yourself. So hit the pause button and try to do 2.1 up to 2.4 for me, and then you carry on with the rest of this video. If I first of all look at question 2.1 and 2.2, well, for 2.1 it says determine the equation of the line of best fit. So I'm going to go to my calculator, enter the X and the Y values in the statistics mode, and I'm going to read off that Y is 27,114 or 27,114,204X plus 2775,3098. Not an X there at the back, making silly mistakes here, just an 8. Now you will see that I went and I rounded off to 4 decimals. But in the exam, you've got to look at the information or the instruction given to you. So what is the next question now? Your next question is, if the trader sold a diamond that was 0.25 carats in size, are they giving you X values or Y values? They're giving you X values. X is 0.25. Then how am I going to get the Y value? Because they're asking you, predict the selling price. Well, I'm just going to substitute in. Getting that answer, I have 27808,03. Now, before I carry on to the rest of the question, let me first ask myself, and I want to ask you, is it fine to predict that Y value? In other words, are you doing interpolation or extrapolation? Well, my lowest X value is at 0.1. Your highest X value is at 0.55. X is 0.25, so therefore I do not mind this. Not at all. It fits in my domain for this sum. So I'm happy. Let's look at the next question. Okay? This question, ladies and gentlemen, is a bit of a weird question, but I love it because it makes me think. Calculate the average price increase per 0.05 carat of diamonds. Now I'm seeing average price increase. So I'm thinking about gradient. But what is the gradient of that straight line? That gradient is 27,114,204 per 1 carat. Now you've got to think. They are asking me per 0.05 carat. So what must I do? I'm just going to multiply this 24 or 27,000 by 0.05, and this gives me a value of 1355.71 per 0.05 carats. So in other words, for every 0.05 carats that we increase, the price is going to increase as well by 1,355 Rand. Initially, ladies and gentlemen, it was 27,000 Rand plus or minus with per 1 carat. So that's why there's this little bit of a discrepancy between the two. Now we get a very, very, very interesting question. Question 2.4. It was later found that the selling price of the 0.35 carat diamond was recorded incorrectly. The correct price is actually 11,500 Rand. So where is that on my table? There is the one I'm looking for. So instead of the 10,000, the now price is actually 11,500. So I put a little dot there. If you want to see it better, I made it larger now there. When the correction is made to the data set, the correlation between the size and the price of these diamonds gets stronger. Explain the reason. Let me ask you this. Does the now point, the fixed point, does it lie closer or further away from the line? It lies closer. Because it lies closer, my R value is going to go more towards 1. Why is that? Because my data sets lie closer to the line. If they, for instance, said to me that shouldn't have been 11,000, but it was 6,000 Rand, and I just put it there with that green blob there, what would have happened to the R value? Would it have gone to 1 or to 0? It would have gone to 0. It is now further away, so therefore the correlation would be weaker as well. Okay? I'm hoping you get this. It is so simple, but man, it is score marks. So therefore, the correlation gets stronger. My apologies for saying the word now so often in this video. You might have lost count. I even lost count with how many times I said the word now. In the next video, I promise to fix it. Now, this is Mr. VG signing out. Have a gorgeous and wonderful rest of your day. I hope you're enjoying this and you are going to ace statistics in your final exam. Keep well. Cheers.